Okay. I assume it's clear, yes, sir. Okay. So, um, wait one sec. Okay. So, good morning, everyone. My group will present about Apache SOLR. Um, my group consists of myself, Haryo, Raka, Mika, and Tio. But apologies in advance. It's not that good, the presentation, because we're not smart. um, yeah. So maybe Raka can explain the first part of the slide presentation. I mean.
Sure. Okay. So, what is Apache Solr? So basically, Solr is an open source Java search platform built with Lucene, which is a high performance full text search engine that can be embedded on an app to provide sort of a library, but it's not capable of standing on its own as a standalone server. So, how does it integrate with Lucene? So, in a way, it's just Lucene made into the server. It provides basic operations which are required by any search application, such as indexing and searching. For requirements, basically, most system can run Solr um, as long as they met the requirements for, like the Java version and the environment that is required. So, what are the features? Since it is using Java, they have provided us with a handful of APIs to potentially help us work around the user's limited capabilities. Solar is also enterprise ready, meaning that it's used by lots of major companies such as Netflix, DuckDuckGo, etc., and can be deployed onto almost any standalone system or cloud, and will still perform well. But most importantly, it is highly scalable and flexible, meaning that it is easily extendable via JavaScript and easy to make the scale larger using Hadoop to generate replicas. So the features are RESTful APIs. So in order to communicate with Solr, it is mandatory to have Java programming skills. Instead, you can use RESTful services to communicate with it. We enter documents in Solr in formats like XML, JSON, or CSV, and get results in the same file formats. And second, full text search. Solr provides all the capabilities needed for full text search, such as tokens, phrases, spell checks, wildcards, and autocomplete. Uh, as previous, I said it is enterprise ready, and according to the need of the organization, Solr can be deployed in any kind of systems, big or small, such as standalone, distributed, cloud, etc. It is also flexible and extensible by extending the Java classes and configuring accordingly. You can customize the components of Solr easily, and no SQL database are needed. So Solr can be used as a big data scale, no SQL database, where we can distribute the search task along a cluster. It also has an admin interface. Solr provides an easy-to-use, user-friendly, feature-powered user interface using which we can perform all the possible tasks, such as managing logs, add, delete, update, and search documents. It is also highly scalable while using Solr with Hadoop. You can scale its capacity by adding replicas. And lastly, it is text-centric and sorted by relevance. Solr is mostly used to search text documents, and the results are delivered according to the relevance with the user's query in order. And for the core, maybe Hario can explain for us.
Please wait. I'll use my headphone first. Okay. Okay. Am I audible? Okay. All right. Currently, we're having a bit of a technical issue because we were meant to actually show you um, directly how it works. So far, we can only get the solar running, but then when I try to add a core, there's some problems that we cannot yet figure out how to handle. But essentially, there are some stuff that we ended up not including in this presentation because we feel like it could have been shown, such as how to start the Solr instance by simply running the Solr command on the terminal, and then how to start it on the foreground instead of the background, and then show the status, how to stop, how to switch ports, and then yeah, how to stop on all ports, because you can actually create like multiple instances of Solr in multiple ports. And but I have to say the most important thing about Solr itself is the Solr core, which is a running instance of Lucene index that contains all the Solr configuration files required to use it. And we would like to apologize because we cannot actually manage all these configuration files that's actually needed for the core. So we cannot actually show you how it works, but yeah, we're still working on that, I suppose. But then basically, how it works is that we need to create a Solr core in order to perform any operations such as indexing or analyzing. And then one application can actually contain one or multiple cores. And then if necessary, the cores, be it, if you have like more than one, you can actually communicate with each other. Yeah, okay, so, okay, so installing Solr itself, I suppose I should have started with how to install Solr. It's actually quite straightforward. You just go to the website, and then you download a zip file that contains all the files for Solr, and then you extract it in the directory you want the installation to be. And then essentially what you do after that is that you just if you want to run Solr, you just go to your terminal, and then go to that installation directory, and then just run start command, which is yeah, you go to the directory, and then you go to bin, the folder bin, and then solr.cmd start. That's gonna start the Solr. That's gonna run the Solr, and the default port, which is 8983. Yes, although you can actually switch the port as well if you so choose to actually run the instance and port 8984, for example. There you can actually use -p and then specify which port you want it to be to actually switch it. Okay, so after you start the Solr, you can connect to the client web interface of Solr using using that particular command. Create -c Solr sample, for example. You can actually name it like any name you want. You can also specify which port again, because you may actually run multiple instances on in multiple ports. Therefore, you need to actually specify which port is it going to be in, because you don't want to mess things up. Even if you actually only run one instance, for example, you actually need to still specify it, even if it runs on the default port, for example. And then the configuration directory as well. This is the part where we couldn't actually get it to work. But yeah, you have to actually specify it as well. Okay, and then yeah, I suppose my teammate will, I guess, explain the next parts about indexing.
Okay, so I will explain about the Solr indexing. So indexing is how Solr reaches for files. It can accept data from many different sources, including XML files, comma separated value or CSV files, data extracted from tables in a database, and files in common file formats such as Microsoft Word or PDF. And loading the data into the Solr can be done in three ways. One is by using the Solr cell framework built on Apache Tika for ingesting binary files or structured files. Two is by uploading XML files by sending HTTP requests to the Solr server. And the third way is to write a custom Java application to ingest data through Solar's Java Client API. Solar's does not actually require a unique ID or primary key in databases if the field name is defined in the schema that is associated with the index. The next part is the searching using Solar. What allows the user to search using the Solar is the request handler, which handles the request. It is essentially a plugin that defines the logic used to search around the data fields. Data types in this field vary. A name field might contain text data. A size field might contain a floating point value, but this is rather flexible. It can be used to process search queries or manage index replication. But to actually search, we have to pass the user query to a query parser, which basically interpret the meaning of the query and pass the parameters to Lucines. Usually, the query parser includes search strings, Boolean logic, and order specification, which will then be passed to the query filter. This will cache the query results and allocate separate cache, improving performance. This, in a nutshell, is what makes Solar fast and reliable. The next part is the search engine basics. A search engine refers to a huge database of internet resources, such as web pages, news groups, programs, images, etc. It helps to locate information on the World Wide Web. Generally, there are three basic components of a search engine as listed below. The first one is a web crawler. Web crawlers are also known as spiders or bots. It's a software component that traverses the web to gather information. The second one is database. All the information on the web is stored in database. They contain a huge volume of web resources. And the third one is search interfaces. This component is an interface between the user and database. It helps the user through the database to search through the database. Okay, so how do they actually work, right? And these are the steps on how they work. Like there are 8 steps that is required to make them work. So the first step is that they acquire raw content. They collect the target contents on which the search is to be conducted. And then the second one is build the document. The next step is to build the document from the raw contents, which the search application can understand and interpret easily. And then before the indexing can start, the document has to be analyzed. After that, the next step is to index them so that this document can be retrieved based on certain keys instead of the whole contents of the document. It is similar to the indexes that we have at the end of the book, where common words are shown with their page numbers so that these common words can be tracked quickly instead of searching the complete book. Once a database of indexes is ready, then the application can perform search operations. To help the user make a search, the application must provide a user interface where the user can enter text and initiate search process. Once the user makes a request to search a text, the application should prepare a query object using that text, which can be used to inquire about the index database to get relevant details. Using the query objects, the index database is checked to get the relevant details and the content documents. Finally, once the required result is received, the application should decide how to display the results to the user using its user interface. I think that's all from my part. The next parts will be explained by my partner.
Okay, so I guess this is my part. So for now, I will explain about scaling. So Solar was basically designed to be a highly scalable while maintaining a decent speed using minimal extra coding. From our understanding, it will be faster to distribute indexes across multiple servers rather than a single server to reduce the workload of said server. To distribute indexes, we will need to partition the indexes, which will then run on separate server, which will then collectively input results. It is advisable to use Solar Cloud when scaling in or out, which simplify things. Legacy mode of Solar. prior to Solar Cloud requires a constant update on Solar config.xml, which will only distribute query result as opposed to Solar Cloud full component distribution query, facet, highlight, stats, etc. Distributed search, however, requires unique keys and documents ID to prevent accidental discard of document itself. Now for the Solar Cloud. In short, it is an environment to distribute indexes across multiple servers. Data will be organized into multiple pieces and distributed across multiple machines with the help of Zookeeper server to manage the overall structure and route research properly. Let's say a data field is too large, we can then partition it into multiple instances. Solar Cloud also provides an API called collection to split shards, negating the risk of predefining the amount of shards needed, which can be risky if something were to change at the moment's notice. And now, for the final part, we can conclude some of the advantage or and disadvantage. Like my friends said, Solar is very quick and it's very easy to search keywords within a document. And then it has the customizability that is so good that anyone can set it up to and customize it for their needs. And for the last advantage, from our opinion, is Solar allows you to build your own custom request handlers and allows you to import data from pretty much any data source. And however, the disadvantages are one of them is it has a steep learning curve. It is not intuitive how to configure or customize it. That is why, like one of our friend, Haryo, has a problem with it. And it doesn't include the web crawler indexing into your website. Requires adding a separate web crawler or using the API to add information to the index. And the last one is debugging or troubleshooting query can be a very difficult task. And now for the last part, I think our friend Nicholas would like to.
Yeah.
Yeah.
Actually, Harriet would like to show the tab. I think it's sort of working right now, the solar. So if you don't mind, we're gonna allow Harriet to show his screen.
All right. Okay. Please wait. Um, okay, so can you guys see it? Okay,
Yes.
so essentially this is how the Solar admin looks like. And oh, maybe I'll just show the entire screen because so you guys can see on which port it is running. Okay, right. Okay, so essentially it's running on port 8983, and this is how it works. It starts 32 minutes ago. Yes, this is the versions, and it runs on Java 11, which is the long-term the LTS version. Okay, so here is there's no course available. Just that's because actually we haven't made one. Um, and then here, essentially, if you are able to set up the configuration files, you're able to create a core here, or you can also create the core on the terminal, just like this. Okay, so first of all, you navigate into the directory, and then you start the Solar instance, and then you can essentially, after you run this, you can open localhost 8983, and then yeah, here you can actually create a core, but yeah, as I mentioned previously, um, we have not been able to get it working. So yeah, that's pretty much how it is. All right, yeah, maybe Master Boss would like to continue.
Yeah. So basically, that's it, sir, from our presentation regarding solar. Apologize for all the hiccups surrounding it. We haven't gotten the thing to work, but I hope it's been an okay presentation. I think I'll close the presentation right now. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Yeah, I think one excellent presentation for me. It's good. Your team has explored a lot in the solar. So yeah, solar is one of the tools. Yeah, especially is very tough and very detailed on the searching some things features in the big data. So I have one question for the current discussion. So what do you think? Is if we using solar, what type of the data source that can be matched and solar can work well on its data sources?
The data source for solar, sir.
Yes. What type of data source that match with the solar works? Yeah.
You mean as in the extension or?
Yes.
Yeah.
Could be extension.
Oh yeah, I mean, Solar pretty much works with a lot of things: JSON, CSV, XML, and then yeah, I'm not entirely sure what.
It basically works with almost anything, sir.
Okay.
Literally. Yep.
Yes. Actually, it's work almost everything. Yes. That's good.
Yep.
Good point. Actually. Okay. Thank you very much for the team. Yeah.
Yes, sir.
Nice. Excellent. Okay. We go to the next team. I think. Please prepare. Rina Putri.
Okay, sir. I will present